Hello everyone, welcome back to the channel. In today's video, we will discuss some of the most commonly asked questions from quantum physics and quantum chemistry, all based on previous year exam papers. If you are preparing for exams like NET, GATE, JAM, SSB or SET, this video is a must watch. I will break down each question, explore the core concepts and provide easy tricks to help you master these topics. Okay, let's start. Number 1. An electron and proton have the same de Broglie wavelength, then the kinetic energy of the electron is. Okay. So here for electron and proton, the wavelength is same. Okay. So we can easily define their momentum from de Broglie wavelength that P equals to h by lambda. So h wavelength is same. So their momentum will be same. Okay. For electron and proton. Now we can define the kinetic energy is given by p square by 2m. So kinetic energy depend on momentum and mass of the particle. So h, according to the questions, momentum is equal. So kinetic energy will depend on their mass only. So kinetic energy of electron will be p square by 2 into mass of electron, and kinetic energy of proton will be p square by 2 into mass of proton. And we know mass of proton is 1836 times greater than the mass of electron. So H this mass of proton is greater. So this term will be lesser. And H the mass of electron will be small. So this will be greater. So from here we can say kinetic energy of electron is greater than the kinetic energy of proton. Okay. So the option D is correct. Kinetic energy of the electron is greater than the kinetic energy of the proton. Next, question number 2. If the ground state energy of a particle in 1D box is 38 electron volt, then the ground state energy that it will have in 3D box. Okay, so we can write down the energy expression in 1D and 3D box. Okay, so in 1D, we know the ground state energy is given by, like, first let me write down the general expression, that is n square pi square h cot square by 2 ml square, and for ground state n equals to 1. So in 1D this is pi square h cot square by 2 ml square, and in 3D the general expression is E equals to n nx square ny square plus nz square pi square h cot square by 2 ml square. Okay, so for ground state nx ny nz equals to 1, so the energy will be 3 pi square h cot square divided by 2 ml square. Okay, so in 3D box, the energy in the ground state will be 3 times the energy in 1D box. Okay, so in 3D box, ground state energy will be 38 times 3. Okay, so this will be 1 for electron volt. So C is your correct option. Next, question number 3. What is the degeneracy of the energy level with n equals to 6 in hydrogen atom? Okay, so remember, degeneracy in hydrogen atom is n square when spin is not included in the system. Okay, so here spin is not discussed, so you can directly write that the degeneracy will be 6 square, so that will be 36. So here correct option is option A. But if spin is included in this system, then in that case, degeneracy will be 2n square. Okay, when spin is included. Next, question number 4. The degeneracy for the energy 17 by 2 h nu in a 3D simple harmonic oscillator is. Okay, so remember, for a 3D isotropic simple harmonic oscillator, the degeneracy is given by half n plus 1 n plus and the energy is given by n plus 3 by 2 h nu or n plus 3 by 2 h got omega. So it is given that 17 by 2 h nu. Okay, so you can calculate that here n value will be 7, n equals to 7. So then only energy will be 17 by 2 h nu. Okay, so if n equals to 7, then the degeneracy will be half into 8 into 9. So it will be 36. So your correct option is option C. Okay, so this is the also case when spin is not included. But when spin is included, then in that case, when spin is considered, then in that case the degeneracy will be n plus 1 times n plus. Okay, next. Question number 5. A particle is confined from minus a to plus a and gives a wave function cos pi x by 2a. The normalization constant for the given wave function h. Okay, so box length is from minus a to plus a, and the wave function is given that cos pi x by 2a. So you can easily calculate this. You have to use the normalization condition, that is from minus infinite to infinite psi star psi dx equals to 1. Okay, so let a is the normalization constant, so psi equals to a cos pi x by 2a. So as the box length is from minus a to a, so the wave function will be defined from minus a to a. So the condition will be minus a to a mod a square cos square pi x by 2a dx equals to 1. So you can easily calculate this integral. So you will find that a will be equals to square root under 1 by a. So C is your correct option. But remember one thing here, whenever the box length is given, like if the box length is given from 0 to L, then in that case the normalization constant will be square root under 2 by L. Okay. And when box length is given like 0 to 2L, in that case normalization constant will be square root under 2 by 2L. So the answer will be square root under 1 by L. Question number 6. Consider the wave function psi x equals to x L minus x from 0 to L for a particle in 1D box, the average value of position h. Okay. So you can define the average value for any operator a, like from minus infinity to infinity psi star a psi dx defined by minus infinity to infinity psi star psi dx. So here your wave function is defined from 0 to L. So average value of position x will be 0 to L psi star. So this is a real wave function. So it will be x L minus x, then x again x L minus x dx divided by 0 to L x square L minus x square dx. So you can easily calculate this integral and you will find that the answer will be L by 2. Okay. So your correct option is option A. Next, question number 7. Which of the following pairs of operator common? Okay, so you can check the options, like let us check the option A. Okay, so d square by dx square dy dx. So let this acting on a function phi. So this will be equals to d square dx square dy dx minus d by dx square by dx square. Okay. So you can say this is dq by dx square minus dq by dx cube phi. Okay. So this will be equals to 0. So you can see this two operator commute with each other. So A is your correct answer. So similarly, you can check other option, they will not commute. Next, question number 8. The operator is, okay, so you have to find whether it is Hermitian, anti-Hermitian, or both Hermitian or anti-Hermitian or non-Hermitian. Okay, so you can check this option easily. Either you can find the uh, total expression for this given operator, or you can directly check. If you like, we define if a dagger equals to a, then the operator will be Hermitian, and if a dagger equals to minus a, this will be skew Hermitian. Okay, so now let us check d by dx plus x minus d by dx plus x. Okay, so if I will apply the dagger on the whole expression, then it will be, we know AB dagger will be B dagger, A dagger. Okay, so this will be minus d by dx plus x dagger into d by dx plus x dagger. So this will be equals to, now see, minus and dagger of dy dx. We know dy dx dagger equals to minus dy dx. So this will be minus, and from here there will be one minus. So it will be plus dy dx plus x. Then from here minus dy dx plus x. Okay. So you can see dagger of whole expression giving us this same expression. Okay, so this will be Hermitian. So the given operator is Hermitian. So A is your correct option. Next, question number 9. The value of commutator LXPY will be IH got PZ. Okay, so A is your correct option. Next, an electron is confined to a box of length 2a times 3a times 5a. The ground state energy of the system in units of h square by 8m is. Okay, so first let us write down the expression of energy in 3D box, and we know this is equals to nx square by lx square plus ny square by ly square plus nz square by lz square times pi square h cot square by 2 ml square. Okay, here it is asking with expression h square. Okay, so you can write this as nx square by lx square plus ny square by ly square plus nz square by lz square times h square by 8 ml square. H code equals to h by 2 pi. Okay, now you can see they're asking for the ground state energy. So nx, ny, and nz will be 1, and you can put the value of lx, ly, and lz as 2, 3, and 5. So you can calculate 1 by 4 plus 1 by 9 plus 1 by 25. So you can calculate this easily. This will be equals to 361 by 900 h square by 8 ml square. Okay, so C is your correct option. Next, question number 11. If quantum particle is confined inside a non-rigid box, then the probability of finding particle just outside the box is very small. Okay, so B is your correct option. Next, question number 12. If angular part of wave function of hydrogen atom is sin square theta cos theta exponential 2i5, then the value of L and M are respectively. Okay, so to find out this value of L and M, you have to remember the general expression for hydrogen atom. Okay, so remember the general form will be exponential ZR by N A naught sin to the power a theta cos to the power b theta exponential I ml I. Okay, so this is the general expression. So from here you can define n. So this will give you the value of n, and from here sine to the power a theta cos to the power a b theta. So L will be a plus b, and from here exponential term you can define your m value. Okay. Now, from the given expression, you can see sine square theta cos theta. So, L will be 2 plus 1 will be equals to 3, and M will be 2. Okay. So, 3 and 2. So A is your correct option. Next, question number 13. The square of magnitude of the wave function is called probability density. So B is your correct option. Next, 14. If the ionization energy of hydrogen atom is X, then the ionization energy of lithium 2 plus is. Okay, so if you see the expression of energy, this is given by minus 13.6 electron volt, 13.6 electron volt, Z square by M square. Okay, so you can see there is a term multiplied with the energy that Z square. Z is the atomic number. Okay, so if you see hydrogen and lithium, lithium is having the atomic number Z is 3. Okay, so a term 9 will be multiplied with the energy. Okay, so if for hydrogen atom it is X, then it will be 9x for lithium. Okay, so your correct answer will be option D, 9x. Next, question number 15. What if A equals to this x minus d by dx, then the value of A square? Okay, so A is x minus d by dx. Now you have to find A square. Okay, so this let this x A square be acting on a function f. So this will be x minus d by dx times x minus d by dx phi. So this will be x minus d by dx x phi minus d phi by dx. Okay, so this will be equals to x square phi minus x d phi by dx minus d by dx x phi minus minus plus d square by dx square phi. Okay, so x square phi minus x d phi by dx. Now from here there will be two term, one minus x d by dx phi minus phi dx by dx, that will be 1 plus d square by dx square phi. Okay, so now from here x square minus 2x d by dx minus 1 plus d square by dx square phi. Okay, so a square will be x square plus d square by dx square minus 2x d by dx minus 1. Okay, so B is your correct. Next, 16. Next, question number 16. For a particle in a 1D box with infinite wall set x equals to 0 and L, okay, and in the n equals to 2 state, the probability for finding the electron in the range 0 to L by 4. Okay, so you can define the wave function like square root under 2 by L sine n pi x by L. Okay, so n equals to 2 means fast excited state, and wave function will be square root under 2 by L sine 2 pi x by L. Okay, so for probability you can easily calculate the expression like from 0 to L, and as it is normalized wave function, so it will be 2 by L sine square 2 pi x by L dx. Okay, but you can see the question, they are not asking the exact value. Okay, so they are asking like greater than 1 by 4, exactly 1 by 4, exactly 1 by 2, or none of the above is correct. For this type of question you can draw the graph and you can tell the answer. Okay, so like see, for this wave function time period is 2 pi by 2 pi by L, so 2 pi to pi cancel, it will be L. Okay, so the wave function will be time period is L. Okay, so that means it will be like this only. So this is your L by 2, this is L and 0. But for probability, the expression is sine square 2 pi x by L. Okay, so here also you can define the time period is L. Okay, but you can see this is square. Okay, so if this is your L by 2, now this is from 0 to L by 2, again from L by 2 to L will be also positive. Okay, So this is your L by 4, L by 4. This is 3L by 2. Sorry, 3L by 4. Okay. Now you can see the probability of finding the particle from 0 to L by 4, L by 4 to L by 2, L by 2 to 3L by 4, and 3L by 4 to L. All part having the same value, and this will be exactly equals to 1 by 4. You can calculate this from this expression also. Okay. So probability of finding the particle from 0 to L by 4 will be 1 by 4. Similarly, for L by 4 to L by 2 will be 1 by 4, and for between L by 4 to 3L by 4 will be half. Next, which of the following pairs of operator commute? Okay, so I think we have already discussed d square by dx square and d by dx will commute. So A is your correct option. Next, if Lx, Ly and Lz are respectively the x, y and z components of angular momentum operator, the commutator Lx, Ly, Lz is equal to. Okay, so Lx, Ly, comma Lz. Okay, so first use the property of commutator bracket. So that this will be equal to Lx, Ly, Lz plus Lx, comma Lz, Ly. Okay, and we know Ly, Lz will be, so here Lx, Ly, Lz will be IH cot Lx plus Lx, Lz, Lx, Lz. So it will be minus IH cot Ly, Ly. So this will be equals to IH cot Lx square minus Ly square. So C is your correct option. Next, question number 19. A particle of mass m is confined in a two-dimensional square well potential of dimension A. This potential Vxy is given as this. The energy of the first excited state for this particle is given by. Okay, so this is a two-dimensional box. You can define the energy nx square plus ny square times pi square h cot square by 2m a square. Okay, and they are asking for the fast excited state. For ground state, nx ny is 1 1, and for fast excited state, the value will be 1 2 2 1. Okay, so it will be, this will be a degenerate state with degeneracy 2, and the value of energy will be 5 pi square h cot square by 2m a square. So 5. Okay, so this will be 2. Okay, otherwise if you will write like this 5 pi square h square, then it will be 8 m a square. Okay, so C is your correct option. Next, question number 20. The Hermitian conjugate of d by dx is minus d by dx. Okay, so B is your correct option. Which one of the following commutator relation is not correct? Here the symbols have their usual meaning. Okay, so this is a very general question and very important question. So you try to practice the commutator bracket for angular momentum component. Okay, as we know, Lx, Ly is IH code Lz. This is correct. L square Lz 0, because remember L square commutes with all components of angular momentum. So this expression is also correct. Then Lz L plus equals to H code L plus. This is also correct. And Lz L minus will be equals to minus H code L minus. Okay. So this is not correct. So D is your correct option. Next, 22. Let L and P be the angular and linear momentum operator respectively for a particle. The commutator of Lxpy gives you IHPZ. Okay. So D is your correct option. Which of the following operators is Hermitian? Okay. d square by dx square is Hermitian. D is your correct option. Remember, d by dx dagger equals to minus d by dx. So this is not Hermitian. But d square by dx square is Hermitian. Again, dq by dx q is not Hermitian. And here, d square by dx square is Hermitian. But if you multiply an imaginary quantity with a Hermitian operator, then that will be skew Hermitian, remember. So this is skew Hermitian. Next, y and sigma z are the Pauli matrices. The expression is equals to. Okay, so you should remember all the properties of Pauli matrices. These are very important questions. Okay, so sigma x equals to 0, 1, 1, 0. Sigma y equals to 0, iota, minus iota 0. Sigma z equals to 1, 0, 0, minus 1. Okay, and remember, the commutator bracket sigma x, sigma y equals to 2 iota sigma z, and they anti-commute. That is sigma x, sigma y equals to 0. Okay, that means sigma x, sigma y plus sigma y, sigma x equals to 0. So, and sigma x, sigma y equals to iota sigma z. Okay, so from the given expression, that is 2 sigma x, sigma y plus sigma y, sigma x. Okay, so I can write this as sigma x, sigma y plus sigma x, sigma y plus sigma y, sigma x. Okay, this expression, you can see the anti-commutator bracket of sigma x, sigma y, and this will be 0. Okay, and this sigma x, sigma y will give you I sigma z. Okay, so C is your correct option. Next, 25. If x and p are the x components of position and momentum operators of a particle respectively, then the commutator x square p square. Okay, so x square p square commutator bracket. So this will be, so you can use the properties of the commutator brackets like xx comma p square. So this will be equals to x p square plus x p square x. Okay, again you can use, or you can directly write the commutator value from here, that is 2 xp ih cot plus 2 ih cot p x. Okay, so 2 ih cot xp plus px. Okay, so D is your correct option. Next, the degeneracy of the third energy level of a three-dimensional isotropic quantum harmonic oscillator is. Okay, so we have defined earlier, degeneracy is given by half n plus 1 into n plus 2. So third energy level. Okay, so ground state is n equals to 0, n equals to 1, first excited state, n equals to 2, second excited state. So it is asking third energy level. So first, second, third energy level. Okay, so Gn will be half 3 into 4. Okay, so it will be 6. So your correct option is option A. The number 27. The normalized wave function of hydrogen atom is denoted by psi, where n, l, m are respectively the principal, orbital, and magnetic quantum number. Now consider the electron in the mixed state. The expectation value of the energy of the electron in electron will be approximately h. Okay. So for this type of questions, we know if a wave function psi is given like c1 phi 1 plus c2 phi 2 plus dot 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 plus cn phi n. Okay, and if it is a normalized wave function, then if phi 1, phi 2, phi n are all are eigenfunction of an operator A corresponding to eigenvalues lambda 1, lambda 2, dot, dot, lambda n, then the expectation value of this operator A corresponding to this psi is given by summation Cn mod square lambda n square. So you can see this psi 100, psi 210, psi 32 minus 2 minus 2 are eigenfunctions of energy. So the expectation value of energy corresponding to this psi n, you can calculate. This is 1 by 9 energy will be minus 13.6 electron volt by n square. N is 1. So 1 plus 4 by 9 minus 13.6 electron volt by 4 plus 4 by 9 minus 13.6 electron volt by 9. Okay, so you can calculate this easily. This will be equals to minus 13.69 electron volt. Okay, so your correct option is option C. Next, 28. The concept of matter wave was suggested by de Broglie. Okay, so B is your correct option. Identify which of the following operator is not Hermitian. Okay, see, this is Hermitian. This is also Hermitian. This is Hermitian. But this operator is not Hermitian. Remember, d by dx is not Hermitian. But d square by dx square is Hermitian. And if you multiply a imaginary part, if you multiply a imaginary part to a Hermitian operator, that will be skew Hermitian. Okay, so here even I is multiplied with d square by dx square. So this is not Hermitian. Okay, so this is your correct option A. Next, question number 30. The difference in energy levels of n equals to 2 and n equals to 1 in a 1D box is 6 units of energy. In the same units, what is the difference in energy levels of n equals to 3 and n equals to 2 for the above system? Okay, so you can see for 1D box, energy with n equals to 1 will be pi square h cot square by 2 ml square. Energy with n equals to 2 will be 4 pi square h cot square by 2 ml square. So the difference will be E2 minus E1 will be 3 pi square h cot square by 2 ml square. So this is equivalent to 6 units. Okay. Similarly, for energy n equals to 3 minus energy n equals to 2, this will be 9 minus 4. So 5 pi square h cot square by 2 ml square. So you can see for this 3 pi square h cot square by 2 ml square, this is 6 unit. So 5 by 3 into 3 pi square h cot square by 2 ml square. So this is equivalent to 6 unit. So 5 by 3 into 6. So this will be 10 units. Okay. So D is your correct option. Next, 31. Consider a particle confined in a cubic box. The degeneracy of the level that has an energy twice that of the lowest level. Okay, cubic box means your three-dimensional box. Okay, so in three-dimensional box, for n equals to 1 or ground state, the energy is 3 pi square h cot square by 2 ml square. Now we have to find the degeneracy of that level which has a energy twice to this energy. So the energy will be 6 pi square h cot square by 2 ml square. And if you see the general expression for energy in three-dimensional box, this will be nx square plus ny square plus nz square pi square h cot square by 2 ml square. And this expression n square plus ny square plus nz square will be 6 only when nx, ny, nz value are 2, 1, 1, 1, 2, 1, 1, 1, 2. Okay, so the degeneracy will be 3. Okay, so your correct option is option A. Find the value of commutator bracket of x in commutator bracket of xh, where h is the Hamiltonian operator. Okay, so you can write h is p square by 2m. So in components form, you can write 1 by 2m px square plus py square plus pz square. Okay, so let us first calculate the commutator of x h. Okay, so x, I'm taking the constant out of this commutator bracket, so 1 by 2m, then px square plus py square plus pz square. Now 1 by 2m x px square, then plus x py square plus x pz square. But we know x py, commutator bracket of x py will be 0, commutator bracket of x py will be 0, commutator bracket of x pz will be 0. Okay. So from here you can write 1 by 2m 2px x px. Okay. So this will be px by m I h got. Now x commutator bracket of xh. So this is equals to I h got by m px. Again, you can take the constant out of this commutator bracket. So I h got by m x px. Again, the commutator bracket of x px is I h got. So I h got by m multiplied with I h got. So this will be equals to minus h got square by m. Okay. So A is your correct option. Next, question number 34. The operator s plus minus equals to sx plus minus isy, where sx and sy are components of the spin angular momentum operator. The commutator sj s plus operator is. Okay, so you should remember this spin operator also gives the same result of commutator bracket as angular momentum. So sx sy commutator bracket is equals to ih got sj. sy sz commutator bracket equals to ih got sx. Similarly, commutator bracket of sz sx gives ih got sy. Okay, so commutator bracket of sz s plus operator. So sz sx plus I sy. So sz sx plus iota sz sy. Okay, so sz sx will give you ih got sy. ih got sy plus iota sz sy. So it will be minus ih got sx. Okay, so this will be iota h got sy minus minus plus h got sx. Okay, so this will be equals to h got sx plus iota sy. So this will be h got s plus. Okay, so A is your correct option. Next, 35. A particle is in a 1D box with a potential V naught inside the box and infinite outside. An energy state corresponding to n equals to 0 is not allowed because the wave function becomes 0 everywhere. Okay, so C is your correct option. Next, 36. The most probable value of R for an electron in 2p orbital of hydrogen atom is. Okay, so remember, for hydrogen atom, the most probable distance is given by n square a naught. Okay, so as it is given that 2p orbital, so n equals to 2. So here the most probable distance will be 4 a naught. Okay, so B is your correct answer. The correct statement about both the average value of position and momentum of a 1D harmonic oscillator wave function is. Okay. So for 1D box, a 1D harmonic oscillator, average value of position is 0 and average value of momentum is 0. Okay. So you can remember for a particle moving under a potential, if the potential is symmetric about point x equals to a, then the average position of x will be a. Okay, so for 1D harmonic oscillator, you can say the potential is symmetric about x equals to 0 point. So average value of x will be 0. And remember, for every real wave function, the average of momentum will be 0. Okay. Similarly, even remember for one dimensional box, their potential is symmetric about, this is 0 to L, this is infinite inside 0. So here you can see potential is symmetric about x equals to L by 2. So for 1D box, average value of position will be L by 2. And momentum again here will be 0. Next, 38. What is the ladder operator relationship for a quantum harmonic oscillator? We know for harmonic oscillator, commutator bracket of A dagger is 1. Okay. Similarly, you should remember commutator bracket of number operator A dagger A cap is minus A cap. Commutator bracket of number operator A dagger A dagger equals to A dagger. Bracket of Hamiltonian operator, number operator, A dagger A cap equals to 0. And if you define number operator A dagger A cap equals to Hamiltonian by h cot omega minus half, then commutator bracket of Hamiltonian operator and A cap equals to minus h cot omega A cap, and commutator bracket of Hamiltonian operator and A dagger, that is raging operator, equals to h cot omega A dagger. Okay, so try to remember this. Next, 39. The value of commutator of x px commutator is. Okay, so you can see x commutator bracket of x px. So for x px, this is iota h cot, and we know commutator bracket of an operator with constant is always 0. Okay, so D is your correct option. The degeneracy corresponding to energy of 2D square box with energy 10 pi square h dot square by 2 ml square each. Okay, so you can see for 2D box, energy is given by nx square plus ny square pi square h dot square by 2 ml square. Okay, and the total energy here is given as 10. Okay, so nx square plus ny square will be 10 only when the value are like 3113. Okay, so here the degeneracy will be 2. So A is your correct option. Next, 41. The value of commutator of this expression. This is Jacob's identity. So this will be 0. So D is your correct option. Next, 42. 4 particles of mass m each are inside a two-dimensional square box of side L. If each state obtained from the solution of the Schrodinger equation is occupied by only one particle, the minimum energy of this system in units of h square by ml square. Okay, so we have a two-dimensional square box. Okay, that means energy can be written as nx square ny square into h square by 8 ml square. Okay, so there are 4 particles. Okay, so we have to find the minimum possible energy. Okay, and it is given that in each state there will be only one particle. Okay, so ground state will be nx equals to 1, ny equals to 1, so there will be one particle. Now in first excited state, nx will be 1, ny will be, and in another case nx can be 2, ny can be 1. So this state has a degenerate state. Okay, so here will be one particle, here will be one particle, and the next particle will be in the next excited state. So that will be nx equals to 2, ny equals to 2. Okay, so the total energy will be 2 plus 5 plus 5 plus 8 h square by 8 ml square. Okay, so this will be 2 plus 5 7 plus 5 12 plus 8 20 by 8. 20 by 8 h square by ml square. So this will be 5 by 2 h square by ml square. So B is your correct. Next, 43. Difference of average values of position for states n equals to 1 and n equals to of a particle confined in a 1D box of length L. Okay, so remember for 1D box, for any state n, the average of position is L by 2. So the difference will be 0, because we have already defined if a particle is moving under a potential and this potential is symmetric about x equals to a, then the average of position will be a. Okay, so you can see in 1D box, this potential is symmetric about x equals to L by 2. So average of position will be L by 2 for all state. Okay, so for n equals to 1, it is L by 2. For n equals to 2 also, it is L by 2. So the difference will be 0. So D is your correct answer. The Hermitian operator among the following is. Okay, so always remember all the physical observables are the operator corresponding to physical observables are Hermitian in nature. So you can see the in option B, this operator is momentum operator. So this is must be Hermitian operator. Okay. So B is a Hermitian operator. Okay, you can check other. This is a constant. This is x. X is Hermitian operator, but you can see this is multiplied with a imaginary part. So whenever you multiply the imaginary part with Hermitian operator, that will be skew Hermitian. In option A also, d square by dx square is Hermitian operator, but again it is multiplied with a imaginary part. So this will be skew Hermitian operator. Next, 45. For a particle of mass m in 1D box of length 2L, the energy of the level corresponding to n equals to 8 is. Okay, 1D box with length 2L. So energy, you can first write the general expression. So this will be n square pi square h cot square by 2m, length is 2L square. Okay, so this will be n square. See, in option it is written as h square. Okay, so n square h square by 8m, from here it will be 4L square. So total it will be 32. So n square h square by 32 ml square. So for n equals to 8. Okay, so for n equals to 8 means it will be 64. 64 divided by 32. So it will be 2h square by ml square. 2h square by ml square. Okay. So D is your correct option. As per the uncertainty principle, del x del py equals. Okay. From uncertainty principle, we know del x del px equals to h cot by 2, but del x del py will be 0. Similarly, del x del pz will be 0. Okay, so here the correct option will be D. Similarly, you should remember there is uncertainty relation between energy and time, okay, that is h cot by 2, and angular momentum and polar angle phi equals to h cot by 2. Next, 47. The operation of the commutator x d by dx on a function fx is equals to. Okay, so you can check this. X d by dx f of x. Okay, so x d by dx. Okay, I am writing only f minus d by dx f d by dx x f. Okay, so x df by dx minus x df by dx minus f, because dx by dx is 1. Okay, so this first two term will cancel out, so this will be minus f of x. Okay, so C is your correct option. Next, 48. A particle of mass m is confined in the ground state of one-dimensional box of extending from minus 2L to plus 2L. The wave function of particle in box is psi naught cos pi x by 4L, where psi naught is a constant. The normalization constant psi naught of the function is. Okay. So we have discussed this type of questions initially. So what we know, this is here the box length is given as minus 2L to 2L. So the total box length is 4L. So remember, in this case, the normalization constant will be square root under 2 by total length of the box, that is 4L. Okay, so this will be equals to 1 by 2L. C is your correct option. You can calculate this also, but remember, in this way, you can check the option. Next, 49. When the operator operates on the function, the result is, okay, so minus h cot square d square by dx square exponential minus ikx. Okay, so this will be two-time derivative of this function. Okay, so minus h cot square minus ik exponential minus ikx. So minus from here there will be one minus. So plus h cot square k square exponential minus ikx. So A is your correct option. Last question, 50. Which of the following is not correct with regard to the uncertainty principle? Okay. So you can check all the options. An electron in an atom cannot be defined by a well-defined orbit. The momentum of an electron cannot be measured exactly. A harmonic oscillator possesses zero-point energy. Measurement of one variable in an atomic system can affect subsequent measurements of certain other variable. So according to uncertainty principle, you can see measurement of one variable in an atomic system can affect the subsequent measurements of certain other variables. This is correct according to uncertainty principle. And also, the harmonic oscillator possesses zero-point energy. Okay, and option A also, an electron in an atom cannot be defined by a well-defined orbit. But the option B, you can see the momentum of an electron cannot be measured exactly. Uncertainty principle say when we are measuring the position accurately, we cannot measure the momentum. But separately, we can measure the momentum of an electron exactly. Okay. So this statement B, option B is not correct regarding to the uncertainty principle. So B is your correct option. Thanks for watching. I hope this video helped you understand the key concept and common questions in quantum physics and quantum chemistry. If you found this video useful, please give it a thumbs up and share it with your friends who are also preparing for exams. Don't forget to subscribe to the channel and hit the bell icon so you never miss an update. If you have any questions or need further clarification on any topic, drop a comment below. I would love to help you out. Also, let me know what topics you would like to see covered in future videos. Good luck with your studies and see you in the next video.